Okay, I'm going to show you about these multimeters that you have in your kits. If you open up the box, there's a bunch of stuff in there, and there's a bunch of stuff in there. Okay, we got the multimeter, two different sets of wires, some alligator clips, and a 9-volt battery. To put in the battery, you need a screwdriver. Open up the back here. Keep the screw, open this up. And if you have to look carefully, and there'll be a plus and a negative, and you look on the battery and there's a plus and a minus. So put the plus with the plus, plop it in there, and close it back up. And then we have these two sets of leads here. And if you open these, you'll notice that one of them has, one of them have metal, the metal tips are exposed, and one of them, the metal tips are covered by plastic coverings. See? And I'm going to, for now, skip the one with the metal coverings. They're really sharp, pointy things that we're not going to need to use. So I would take this one with the covered tips and just hold on to it. We're not going to probably use it for now. The one with the exposed metal tips, I'm going to open up. And then there are these things plug into the multimeter, and these things have the exposed metal tips. And then there are these alligator clips that I want to use, but it turns out that they're covered with this black and red plastic thing to try to keep them insulated, but they actually really get in the way. So I would take these out of the metal of their plastic clips. And actually I found a good way to do that is you use one alligator clip to pull the other alligator clip out. So if I open these up and grab that clip with that one, I can pull that out and then pull that one out. And you can keep these, just put them in the box, maybe with this other set of leads. Okay, and now these alligator clips can slide onto. Now these alligator clips can slide onto the sharp points of these things. Be careful not to poke yourself because they're sharp. Okay, now I've got two leads with alligator clips. And we got a black one and a red one. So the black one I'm going to put in the jack marked COM for common. That's basically our ground. And then the red one goes in one of these three leads, depending on what you want to measure. And this one says volts, and then it's got an omega and an HZ for hertz and a bunch of different other things. So that jack is used for lots of measurements, including the V for voltage, and these other two are mostly for measuring current in amps. So to say we want to measure voltage, I'll put it in that one. I have my two leads. Okay, let's go through these settings. So if I turn it on, the first setting is a V with a little sine wave thing on the top of it. That is for measuring volts, but alternating volts. So more like what you'd get if you with the power outlets in the wall. Almost everything we're going to do for a while is in DC voltage, meaning it's a constant voltage. It doesn't vary. An AC voltage varies up and down, but a DC voltage is just constant, and that's the V with the straight line over the top of it. So that's what most we're going to use. Then the next setting is in millivolts, so it's just a different range. You'll notice when I put this on AC, if I look, whoops, where'd it go? If I put this on AC, you can see it says AC up here in the window to remind you. And if I change it to DC, it says to DC, so you can pay attention to that. If I put it in millivolts, it says DC, but then on the meter, there's a yellow thing that says AC, and that you can change to the yellow by pushing the yellow button. So if I push select, See, it changes to AC and then back to DC. So in case you had just you wanted to measure small voltages, you'd use the millivolt range. If I change it to this next one, I get all sorts of things, but the main one, the first one, is ohms, which is measuring resistance. So if you wanted to measure the resistance of something, you'd use that. Then you can do, this thing is hertz, which measures frequency, and then there's a bunch of different current setting, amps and milliamps and microamps. But we will leave those off for now. The range button, usually at a range, it automatically sets the range. If you wanted to set different ranges, you can use that range, but let's put it on so it says, if I keep pushing that, there we go. If I push it and hold it, it says auto, and I don't know what the APO stands for, sorry. And you can also do a min-max, so you can have it tell you the maximum value or the minimum value and just hold that number on, but we're not going to use that for now. Okay, so when I have this on voltage, what is it actually measuring? So if I remember again of my hill thing like that, and I think about voltage as the height of my hill, if I put my two leads here someplace on a circuit, it's going to measure the height difference between the black lead and the red lead. It's not going to measure from ground. It's going to measure the change in height from wherever my black lead is to my red lead. So if I put my black lead there and my red lead there, it'll measure that difference. Or if I put it there, it'll measure that difference. What happens if I switch them and I put the black lead higher than the red lead? It'll give me a negative number. So that's what a voltmeter does, and you can touch it any two places on your circuit or clip it on to any two places on your circuit, and it will tell you the change in height or the change in potential, the change in voltage between those 2 points. Okay, as an example, let's measure the change in height, the change in voltage between this one end of this battery and the other. Have a little AA rechargeable battery here. If I hold the black lead to one end and the red lead to the other end, you see it says 1.17 volts. Most AA batteries are 1.5 volts, but rechargeable batteries are more like 1.2 volts. Now if I switch it and I put the black, on the positive end of the battery and the red on the negative end of the battery, you'll see the meter reads negative 1.2 volts. Okay, just to show you what happens if I switch this to millivolts, and now I try to measure the voltage of this battery. I'll put the black on the negative and the red on the positive. It says OL for overload, and that's not going to hurt the meter. It's just saying I can't measure that big a number in millivolt range. Okay, here's another example of what we can do. If I have a resistor, you're going to do this later on. If I have a resistor and I want to say, how much resistance is this thing? I can switch this to the resistor measurement, and it happens to be that the red and black leads are in the same place for a resistance measurement. So you want to make a good connection. I can just connect these alligator clips to both sides of this resistor, and it says 0.993. And you want to say, well, what units is that? And it tells you up at the top, that's kiloohms. So this is about 1.99 is about 1,000 ohms. Yeah. So that's how you measure a resistor. When you measure a resistor, you have to be careful that there's nothing else in the circuit. Like you wouldn't want to have the resistor connected to a battery while you're trying to measure its resistance. You need it to be isolated. So if you wanted to measure current instead of voltage, it's not as easy as just taking the two probes and touching them to two different things on the circuit. It gets more complicated, and we'll explain that more in future labs.